This video isn't really a tutorial. I wouldn't really even consider it a review. I'm basically just going to try and show the difference between the Blackmagic Design Intensity Shuttle, the USB 3.0 version, as well as the Canopus ADVC 110. To get the demonstration started, I'm going to use the EDIA software by Canopus. This is just a real simple standard definition timeline. It's actually the 4:3 aspect ratio, but I put an HD clips in there, so it kind of looks like it's more like 16:9 aspect ratio, but it's actually not. We can see we're getting real-time effects. This is really super, easy to do. It's just standard definition. EDIUS can play standard definition video to the broadcast monitor just fine using the Canopus ADVC 110. I want to let people know what you're seeing on the computer screen, the secondary computer screen, is 1920 by 1080 resolution. This is a high definition timeline. But what you're actually seeing on this particular monitor and what you're seeing on this particular broadcast monitor is 720 by 480 resolution. In order to output to the older CRT monitors in standard definition, you have to actually go into the control panel for the Intensity Shuttle Pro. In the conversion option, you have to actually opt for HD to SD, and they give you a letterbox option, which is what I opt for, so it'll letterbox the top and bottom instead of stretching out the video clip to fill the screen. So I'm just going to hit save. Nothing really to do other than that. And then when I hit play, we can see that image, you're not going to see it on YouTube. That is really crisp and clean. It is true HD. This is, like I said, DVD quality. The motion graphics are smoother on these two monitors than you're ever going to get on a computer monitor, because this is actually a 1920 by 1080i timeline. It's an interlaced timeline. EDIUS can play a high definition resolution timeline to a standard definition monitor using the Intensity Shuttle, because the Intensity Shuttle has hardware that is rasterizing down the 1920 by 1080 image down to 720 by 480. In order to do that, it actually outputs to the HDMI port as well as the component port and the S-Video port at standard definition resolution. What I'm going to do is actually do a zoom real quick, because you can actually watch it like this as well. Most of your TV remotes will actually give you zoom features, so you can do the same stuff I'm doing. And this will clean up the image quite a bit, because we're not stretched out across the whole screen. It is stretched out somewhat from what it would actually be as far as pixel resolution is, but it looks really super clean on here. Obviously, I can't stress it enough. Standard definition looks great on a standard definition monitor. In the next video clip, EDIUS is going to play high definition video from the timeline to the high definition broadcast monitor. So the motion graphics is really smooth, but not only that, the video quality, it just looks better. This image just looks better than what you're going to get on the computer monitor. Plus the color is going to be more accurate. And one other thing that you're going to notice too is that the composition is going to look slightly different. I'm not sure if I can get a really good image that'll show the composition. Oh, this will probably do it right here. As you can see, there's a slight amount of space where this picture-in-picture is, but when you actually look on this monitor, you see that it's getting chopped off. And that's what they usually say. When you got the broadcast equipment to monitor your work, you're going to get a more accurate composition, smoother motion graphics with interlaced footage, and you're also going to get better color accuracy. So there's three things that you'll get by using, professional broadcast equipment that you won't get watching it on your computer monitor. EDIUS can play high definition video to the high definition broadcast monitor using the Intensity Shuttle. Since we are not down converting high definition to standard definition, you will not see the video play on the older standard definition monitor. I'm going to go down to the advanced video. I'm going to hit enter. And what I'm going to do is I'm going to do the overscan is on, and I'm going to actually switch it to off. Now, as you can see, where those pixels are, they're not getting chopped off. As you can notice, where like the chair is and stuff, and even up here where the umbrella is, like I said, we can see a slight color shift between them, but now we're getting the images exactly the same. Overscan will use all the pixels, even the ones hidden by the bezel of your computer monitor or your TV. Underscan will shrink the image slightly so that no pixels are hidden by the bezel. I am now going to use Premiere Pro to do the demonstration of the Canopus ADVC110 and the Blackmagic Design Intensity Shuttle. I'm going to start off with the Blackmagic Design Intensity Shuttle. I do have a 4K timeline. I'm actually editing Red 1 native codec at 4K. And if I hit play, I can get plenty of real time. It's sending the timeline to the Blackmagic Design product, and we're seeing it on my broadcast monitor. Premiere can play 16:9 aspect ratio at 4K resolution to the broadcast monitor just fine using the Intensity Shuttle. I don't think that is a feature of the Intensity Shuttle. I think it is because Premiere Pro has an option to output unsupported formats. I think it's great that Premiere will allow you to watch a 4K timeline or project on an HD monitor. It will not, however, let you take a 4K project and rasterize that all the way down to standard definition to be seen on the old standard definition CRT style monitors. What I want to say though is that if I actually go into the Red 1 codec and I actually have, this is not a 4K, it's a 4.5K clip. It's got a little bit more resolution, but that's really not the issue. It's the fact that, as you can see, the image isn't coming out right. They're kind of stretched out. It really should be letterboxed. With Premiere Pro using the Intensity Shuttle, it is able to actually output 4K, and it could probably actually output 6K to the Blackmagic Design product, provided it's got the 16:9 aspect ratio. The Blackmagic Design product really only works with broadcast compliant, formats and aspect ratios. In the next video clip, we will see if the Premiere Pro software, when combined with the ADVC110, can play 4K formats with odd aspect ratios. As I go into the 4.5K, which has a different aspect ratio, as you can see, it actually displays it correctly. If you did do something for the web, you did something that was like 1800 pixels by like 400 pixels, so it's like this really super skinny, like flash banner type, setup. You could do client previews, using the CRT monitor if you wanted. If you didn't have, all the other monitors, you just had a CRT monitor. When using Premiere Pro with the analog to digital video converter from Canopus, you can output 4K timelines to that particular product, and you can actually have weird aspect ratios. You can have 2:1. You can actually go in and create like an 1800, pixels by say 450 pixels, and it will output it correctly to the broadcast monitor. The only problem is that you're stuck with standard definition resolution. That is it for now for the Canopus ADVC110. I'm going to go back to the Blackmagic Design Intensity Shuttle now. I'm going to hit play real quick. Like I said, we're getting DVD quality here, DVD quality here. You can see there's better resolution on that monitor because that is playing it back at high definition. This monitor is playing it back at standard definition because it's using the Blackmagic Design product. I hope that I'm explaining this correctly. Now, some people say, wouldn't the client want to see, the high definition image? Well, even though this is standard definition, all the little, intricate little patterns that you've seen on that fireplace, how you have different patterns in it and different textures in it, they come through on the standard definition monitor just fine. It may not have all the clarity that the high definition image would have, but it still looks super crisp and clear. And the reason why I used to do client, previews on this monitor using the DV converter is because the interlaced footage just plays back really silky smooth. Blackmagic Design is doing a really good job at rasterizing down the image. The motion paths look a lot better.
It is great that the Intensity Shuttle can take high definition timelines and output them to standard definition monitors. As I stated with the EDIUS software, all the outputs have to be in standard definition mode. You cannot actually have the HDMI port be in high definition output mode while simultaneously having the S video output in standard definition mode. The Intensity Shuttle will not do that.
So now I can hit play. And once again, like I stated before, yeah, this image does look better than that image. This is just, there's a lot of panning and jittery camera movement. And whether you're using Final Cut Pro, Avid, the EDIUS software even, interlaced footage is just going to look jerky. It's not going to look as smooth. You really do need the third-party hardware. The motion graphics plays back silky smooth.
As you can see, Premiere Pro can output a high-definition timeline to a high-definition broadcast monitor very easy using the Intensity Shuttle. But just like with the EDIUS software, since it's in its high-definition mode and it is not being down-converted to SD at all, it will not show up on the old standard definition CRT monitor.
Now we're actually seeing Premiere Pro make use of the DV converter to output a high definition timeline. And the only thing I want to say is that the image looks horrible.
Premiere Pro can play high definition timelines to standard definition broadcast equipment using the Canopus ADVC110. However, if you use GPU acceleration, the image looks horrible. If you use CPU acceleration, the image quality will look pretty good.
And this is actually only at 320 by 240. So I'm going to hit play really quick. And it doesn't look bad on this computer monitor because the image is only like an eighth of the screen. But on that, it looks horrible. And if I hit the tilt key, it's going to look horrible. It looks fine on here because it's a standard definition resolution.
Premiere Pro can play standard definition timelines to a standard definition broadcast monitor using the ADVC110. The ADVC110 is only standard definition. It's not designed for high definition. If you wanted to connect the ADVC110 to a high definition broadcast monitor, you could do it by connecting the S-Video out of the ADVC110 into an HD monitor. You're only going to get standard definition resolution, and that is why it'd be better to watch your timeline on a standard definition broadcast monitor.
And I want to let you know, if a client was actually here right now, this is 400 by 300 lines of resolution, this actually looks decent. And that's why I was going to get rid of my CRT monitor, because you're like, wow, that doesn't look bad at all. A client, or if anybody watching this on YouTube was to see it, you'd say, wow, that looks fantastic. Until you see it on an SD monitor, on a standard definition monitor, it just looks so much better.
Premiere Pro can play standard definition timelines to a standard definition broadcast monitor using the Intensity Shuttle. The EDIUS software can do the same thing. Some of you may be a little bit confused about what the capabilities of the two software programs are, as well as the capabilities of the two hardware devices. I have created a chart that should make things a lot easier to comprehend. I'm not going to go over the chart in this video because part one was really just supposed to be a demonstration of what the third-party hardware products are capable of. That's why I mentioned the overscan, underscan capabilities in this video. I also made mention of the zoom features. I stressed that it's better to watch standard definition video on a standard definition monitor, and it really is, folks. As far as Premiere Pro and EDIUS, I wasn't really trying to battle the two of them out. I did want to actually use two different software programs so that people could see that different programs are going to actually take advantage of these two products differently. Where would Final Cut Pro 10, Avid, and Vegas show up on this chart? That I don't know, but I do plan on testing those other software programs in the not so distant future. Part 2 of the video, I will go over this chart in more detail, although some of you can probably look at the key or legend at the bottom and figure it out for yourself if you watch the video again. I'll go over pricing, ease of use, I'll go over pros and cons of each of the products, and I'll actually compare them to other third-party capture devices on the market. That's going to wrap it up for this video. I hope you'll watch part 2.